शिफ्ट लेके सब लोग चेक कर रहे हैं कंटिन्यूस, तो पता चल गया, नहीं तो वो भी सर, और ऊपर से 60 सीट्स पर तत्काल की तरह बुक हो जाती हैं सर।
राइट बेटा, दैट्स राइट।
मुंबई एमएमटी, बाकी एमएमटी 300 सीट्स, इतनी सर पता नहीं क्या प्रॉब्लम है इनको।
60 नहीं थी इस बार तो 150 सीट्स आई थी।
कितना बड़ा है क्या इस बार?
हाँ 150 सीट्स आई हैं सर।
चलो थोड़ा तो सुधरे यार एटलीस्ट। तो
ओके
कुछ
सो
करिए
बेटा,
सर, आप कर सकते हैं सर कुछ।
हाँ, आज का टॉपिक हम लोग शुरू करें।
आज चार्ट वर्क था ना?
हाँ बेटा, चेंज हो गया, देयर इज ए स्लाइट चेंज। चार्ट वर्क यू हैव टुमारो एंड सेल नैव टुडे।
चलो ठीक है सर, डाउट्स पूछ लेते हैं फिर।
ओके सो बेटा, आज का जो हमारा टॉपिक है, लास्ट लेक्चर वी डिड द रैशनल हॉराइजन डायग्राम कॉन्सेप्ट, द PZX ट्रायंगल. We understood the celestial sphere, the equinoctial system, horizon system. What are the different parts of the PZX triangle? So that was the basic understanding. Now we are moving into part C of our paper. So part C जो है हमारे पेपर का, उसमें जो हमारा क्वेश्चन नंबर 7 है, क्वेश्चन नंबर 7, most of the time this question number 7 comes on the topic of stars suitable for sight or stars suitable for observation. So
सर
यही
तो एक दो डाउट थे सर, सीएन के बताएंगे कि बाद में सर डिस्कस करेंगे?
बेटा, let's first cover up the topic and
ठीक है
फिर उसके
सर।
बाद डाउट्स को पिकअप कर
कैन यू
लेते
रिपीट आपने क्या बोला अभी?
ओके
आई
सर।
गॉट डिस्कनेक्टेड। आपने क्या बोला अभी 1 मिनट पहले? Can you repeat?
हैं। No issues बेटा, I just asked them how is the weather, so
यही
nothing, don't
डाउट्स
worry,
कंटिन्यू करेंगे।
relax, don't worry. So we are moving into part C of our paper and question number 7. Question number 7 comes on the topic stars suitable for observation. Now this topic is not there in second mates, so it's a slightly newer topic. And दूसरी important चीज बेटा इस टॉपिक के साथ है, this topic is not adequately covered in any of the textbooks. Books में ये टॉपिक अच्छे से covered नहीं है. PracNav में there is a chapter on this topic, but most of the answers they have errors. So when you do that exercise, it creates more doubts than gives you the solution. So we will be going into this topic, and मैं पहले आपको कुछ एक basic concepts के बारे में बताऊंगा, which are required for solving these questions. These are concepts like stellar magnitude, the brightness of the stars, and information given in stars table. Almanac, we have page 268, there is a stars table. So you can keep a almanac close to you. We will be going into that table and we will be seeing what all information is there. All that information is required in these questions. And तीसरा concept जो मैं आपको करवाऊंगा, that is the concept of twilight. So stellar magnitude, stars table and twilight, ये तीनों ही concept हमारे mind में clear होने चाहिए before we go or attempt this question number 7 on stars suitable. जो चीजें मैं आपको करवा रहा हूँ, जो कॉन्सेप्ट्स मैं आपको करवा रहा हूँ, फिर मैं इसकी एक टेक्निक बताऊंगा कि ये क्वेश्चन को हमने कैसे करना है. वी हैव डिवाइडेड इट इनटू टाइप्स. सो हर एक टाइप के क्वेश्चन को कैसे हमने सॉल्व करना है, उसका स्टेप वाइज मेथड मैं आपको सेपरेटली भेज दूंगा, सिंस दिस इज नॉट कवर्ड इन द बुक. So I'll be sending it to you separately and I'll give you a assignment to do. So that is going to be the plan for today. So shall we go into the topic, beta?
So about stellar magnitude while we are doing stars, आपने कुछ तो छोटा सा इंट्रोडक्शन दिया था. The minus sign on the left side of the almanac usually gives the luminosity of the stars. That is the one, stellar magnitude.
Don't worry, I'll explain it again. Don't worry. Right from beginning to end, I'll tell you. Okay, so let's go into the presentation and first see the basic concepts. So let me set up the presentation.
आवाज आ रही है?
In this presentation, we are going to discuss the concept and topic of stars suitable for observation. Now, this particular method, stars suitable for observation, is used to ascertain or find out which stars will be suitable at the time of twilight for a particular observer if he wants to use a specific method of sight or a specific method of observation like meridian passage, Marpas, or latitude by meridian altitude, or X meridian. So basically this means that if a observer wants to take a star sight at the time of twilight, twilight is the only time when a star sight can be taken. So he wants to take a star sight, but he wants to use a specific method. He wants to use a particular star for meridian passage or for a X meridian sight. Now, how to find out of so many stars which are visible to us in the sky, which of them are suitable for the Marpas observation or for the X meridian observation? That is the meaning of the topic, stars suitable for observation. Now, before we go into this topic, we need to understand a few basic concepts to familiarize us with the method and procedure which we use to determine which stars are suitable for meridian passage or X meridian. Now we understand that only those stars will be suitable for a Marpas observation which cross the observer's meridian during the twilight time. Meridian passage sight is taken at the time of the celestial body crossing the observer's meridian. And if we want to use a particular star for X meridian sight, we are aware that that particular star should be within the X meridian limit. So we need to check the X meridian limit for the observer for that particular body, and we need to make sure that the particular star is within that X meridian limit to be suitable for a X meridian observation. Now, the basic topics which we need to understand before we jump into this topic are number one, the concept of stellar magnitude, and number two, the concept of twilight. So we are going to understand these concepts one by one. So shall we move ahead, beta?
Yes, sir.
Yes, sir.
Very good. Let's first go into the concept of stellar magnitude. Stellar magnitude is a scale used for specifying the apparent brightness of a star as observed from the Earth. The magnitude number decreases as the apparent brightness of a star increases. You can see this diagram showing some specific celestial objects, celestial bodies, and also their stellar magnitude. You can see the brightest object in the sky which we have is the sun, and it has a stellar magnitude of minus 26.8. Now, as I told you earlier, the magnitude number decreases as the apparent brightness increases. So the celestial body having maximum brightness is the sun, and it has the minimum magnitude number. The magnitude number of the sun is minus 26.8. Now, after the sun, we have the moon, the second most bright body in the sky, and the stellar magnitude of the moon is minus 12.5. Then after the moon, we have the planet Venus. When it is at its brightest, it has a stellar magnitude of minus 4.4. Then we have star Sirius having a stellar magnitude of minus 1.5. Then Alpha Centauri, the nearest star to us after the sun, having a stellar magnitude of 0.0. Then Betelgeuse 0.8, Polaris 2.5. Now the limit of the naked eye is stellar magnitude 6.0. These stars with magnitude 6.0, very faint stars, barely visible to the naked eye, are the 6.0 magnitude star. They are also called as sixth magnitude star. The brightest of the stars which we have, like Betelgeuse, Alpha Centauri, Sirius, they are called as the first magnitude star. So faint stars barely visible to the naked eye, sixth magnitude star, and the brightest of the stars coming under the first magnitude stars. Now, if you go little more further, if you use a binocular to observe the sky, you would be able to see the stars having a stellar magnitude up to 10. If you have a 1 meter telescope, it can help you to see the stars up to a stellar magnitude of 19. Then another important telescope which we have, Hale telescope, can see the objects having a stellar magnitude of 27. And the most powerful telescope which we have, the Hubble telescope and the Keck telescope, they can help you to see the stars, celestial object with a stellar magnitude number 30. So a diagram giving us a comparison of the brightness as well as the stellar magnitude of different celestial bodies. So any doubt up to here, beta?
So in nutshell, it means from sixth magnitude star to first magnitude star are visible to naked eye, correct?
That's right, beta. That's right.
So can you repeat which are the first and the sixth one?
Ask again, beta.
So which are the first magnitude stars?
Okay, so what is the definition of a first magnitude star and what is the definition of a sixth magnitude star, right?
No, sir, just the names. Which are the names?
Okay, there is no one star, beta. There are a group of stars which fall under first magnitude and we have a group of star which fall under sixth magnitude also. मैं आपको बताता हूँ कि कैसे हम उनको फर्स्ट और सिक्स्थ के नेमिंग देते हैं.
Okay.
Now a first magnitude star is 100 times brighter than a sixth magnitude star. We can also calculate, if we have two celestial bodies, their stellar magnitude known to us, we can calculate how many times a particular celestial body appears brighter than the other celestial body. We have a formula which can be used to calculate the relative brightness, and that formula is relative brightness of a body compared to another celestial body is equal to 2.51 raised to power x. Now what is x in this formula? X is the difference between the magnitudes of two bodies which are being compared. So if you are given two celestial bodies, their stellar magnitudes are known. You can find out the difference between their stellar magnitudes. 2.51 raised to power that difference gives you how many times a particular body is brighter than the other. So clear, beta? It is clear up to here?
Yes, sir.
Very good, beta. Great. Let's move ahead. Now we have seen the stellar magnitude of the stars. We know that the faintest of the stars are of magnitude 6.0 and the brightest of the stars are magnitude 1 star. Now these stars are categorized basis their brightness. We have put them into categories. Now what are these categories? All the stars having their magnitude less than or equal to 1.0. That also includes the star in the negative stellar magnitude range. So all the stars having magnitude less than or equal to 1.0 are called as first magnitude stars. This is a group of the brightest possible stars in the sky, and they are the most preferred stars for the purpose of sight taking or for the purpose of observation. We always prefer to have a first magnitude star for our sight taking purpose. They are the easiest to spot in the sky, being the brightest. Now stars having magnitude greater than 1.0 and less than equal to 2.0 are called as second magnitude stars. In case you are not able to find a suitable first magnitude star for the purpose of sight taking, you can also choose and pick up a second magnitude star. They are also bright enough to be used easily for the conveniently for the observation. Now after this, stars having magnitude greater than 2.0 and less than equal to 3.0, they fall under the category of third magnitude stars, and so on. 3.0 stars having magnitude greater than 3.0, less than equal to 4.0, fourth magnitude. Stars having their stellar magnitude greater than 4.0, less than equal to 5.0, fifth magnitude, and so on. Now, why are these categories important? Because in the questions, they sometimes ask us to find out the first and second magnitude stars which are suitable for a particular observation. So in that case, we check their magnitudes from the almanac, and whichever magnitudes fall under our required category, we pick up those stars and write them as our answer.
So you made one statement like a minute back saying that these magnitudes are both for plus and minus, right?
That's right, beta. First magnitude stars include all the stars which are having a magnitude equal to or less than 1.0. That includes the star having a negative stellar magnitude.
Oh.
Okay, beta, clear?
Yes.
Very good, beta. Great. So if this is clear, we can move ahead, right?
Yes, sir.
Great, beta. Let's go. Now going further, we need to be familiar with the stars information table given on page number 268 of the 1992 almanac. Let's have a look at that table. We have the left hand side page of the table. This is page number 268 of the almanac. And now you can see on the right side is the right hand side page of the stars table. That is page number 269. Now this table gives us the required information about the stars. The first column which you see gives us the magnitude number of each of the star. The second column gives us the name and number of the star. After this, you see the next column of the table gives us the SHA and declination of the stars from January to June. For the first 6 months of the year, the SHA and declination is given on the left hand side page. You have the SHA given first, later on followed by the declination of the star. Now we are aware that the SHA and declination of the star does not change much. There is a very minute change in the SHA and declination of the stars. They can be practically assumed to be fixed bodies on the celestial sphere. So that's why you see in this particular table, the degree values of SHA is mentioned in the beginning, and the minutes are mentioned under each and every month. Now the change in SHA, what happens is happening only in the minutes. The degrees usually do not change. So under every respective column of the month, you see the minutes value is given. So you pick up the degree value from the first column, and then you pick up the minutes value from whichever month you require the value for. The same is done with the declination. You see the degree value is given initially in the first column, followed by the minutes value for each and every month. And you can see here that the value changes by a certain minutes every month. The change is very, very gradual and slow and not very significant. Now on the right side of the page, we have the SHA and declination of the stars given from July to December. So the right side page gives us the required information for the last 6 months of the year, July to December. You have the SHA and then followed by the declination. Again, the same format is used. Degrees are given in the beginning and number of minutes are shown under each and every month. Now the stars are listed in this table as per increasing order of their SHA, sidereal hour angle. You can see the stars starting in the table from 000 SHA going up to 360 degree SHA. So the first stars which you see is 5 degree SHA, the next one 13, 14, 15 and so on. So if you want to identify or pick up a star from its SHA value, this table is very convenient to use. You can enter into the SHA value column, and whichever SHA value you require, you can identify that particular star from this table. Now the left side page of the table gives us the Latin names of the stars. The names which are mentioned here in this particular column are the Latin names of the stars, along with the SHA and declination from January to June. Whereas the right side page which we see gives us the English names of the same stars. And also, as we discussed just now, it gives us the SHA and declination of the star from the month of July to the month of December. So important thing to remember here is whether you go to a particular star on the left hand side page or you go to that particular star on the right hand side page, it is the same star mentioned. Only thing is the names given on the left side page are Latin names, and the names given on the right hand side page are English names. To give you an example, pay your attention to the number 2 star which we have on our list. On the left hand side page, you see the number 2 star which we have is Alpha Pegasi. Whereas if you go to the right hand side page of the table, the same star is mentioned as Markab. So on the left hand side Alpha Pegasi, on the right hand side Markab represents the same star. Alpha Pegasi is its Latin name and Markab is its English names. Now as far as our exams are concerned, we always use the English names of the star. So whenever you are required to identify and list down the stars, you will be picking up the English names, irrespective of the month of the year. whether it is January or June or July or December, any month of the year, you will be picking up the names in English. That means the name from the right hand side page of the table. So if you are picking up the second star, even for the month of January, the star will be named as Markeb and not as Alpha Pegasi. So any doubt in the table, beta?
Sir, in the bottom of the table, there is two numbers, 3.0-3.7. What is that?
Okay. Now बेटा जो आपको ये नीचे नंबर्स दिखाई दे रहे हैं ना, उनके साथ एक सिंबल बना हुआ है. Is there a symbol?
Yes, sir. 2 plus joined together.
Very good. अब आप उसके ऊपर वाली लिस्ट में देखो, किसी एक स्टार के आगे भी वो सिंबल बना होगा, राइट?
Yes, sir. Hercules.
Very good. So it basically says that star Hercules doesn't have one single magnitude. The magnitude can vary and the range within which it can vary is given at the bottom of the page.
Okay, sir. Thank you.
Okay. So you can have certain stars in the list which may have their magnitude varying. So if there is any variation in the magnitude, they give you at the bottom of the page the star against that star name or that symbol which is there in the star name. You will have a range of stellar magnitude. So the magnitude of that star within that 1992 year can be of any value within that range.
नंबर क्या है सर? 57.
Okay. बेटा ये जो numbers हैं, these are basically referring to a separate list of stars which are given in the almanac. ये हमारे almanac में नहीं है क्योंकि इसमें सिर्फ selected pages हैं. Complete almanac अगर आप देखोगे तो उसमें आपको ये list मिलेगी. In fact, Principle of Navigation में 1972 का almanac है. So if you just for your information, if you want to see तो वहाँ आपको ये list मिल जाएगी. So this number is referring to that particular list. हमारा इस नंबर के लिए कोई भी यूज नहीं है. This will not be required in our questions in any way.
सर कौन से वाले नंबर की बात हो रही है? ये 57 की?
That's right बेटा. किसी स्टार के नाम के आगे आपको नंबर भी मिलेगा 57, 56, 55. So for our purpose, this number is not used. This number is not required. Right beta? Clear?
Yes.
Very good beta. Great. So let's move ahead then. We move ahead now. Let's now understand the concept of twilight. Now twilight is the light received from the sun when the sun is below our horizon. Now we receive the light from the sun when it is above our horizon and we call that light as sunlight. But we also receive some light when the sun is below our horizon and close to it, and that is the light which we call as twilight. This happens before sunrise in the morning and after sunset in the evening. So as you can see in this diagram, the right side of the diagram represents the sunrise, and before sunrise for this particular period, the dark blue color sector which is marked here on the right side of the diagram represents the period when we get the twilight. And when the sun goes on the western horizon, you can see in the diagram, the sun going in the western horizon sets at this particular instant, and after setting we keep on receiving the light which is called as twilight when the sun is in this dark blue color sector. So in this particular sector we receive the twilight in the evening. Now, even though the sun is below our horizon, it still illuminates the upper layers of the atmosphere. Now, this happens because of the refraction and scattering principle. The light undergoes refraction in the atmosphere and it gets scattered in various directions, because of which we are able to see the light even after the sun has set or the sun has gone below our horizon. So up to here is clear, beta?
Yes, sir. So just one doubt. So
Bolo
what is
beta.
the exact difference? Like, what is twilight, dawn, and dusk? What is the difference exact?
Okay, beta. Dusk basically means late evening. So evening twilight is known as dusk twilight, and dawn is basically early morning. So dawn twilight is the twilight which happens in the morning.
Okay, sir. Okay.
Okay.
But the entire process is the twilight, where the sun is below the horizon. That is called twilight.
Yeah, sun will be below the horizon, beta. If the sun is above the horizon, we call it sunlight.
Okay, and below twilight. Okay.
That's right. Whatever light we receive from the sun when it is below the horizon, that is twilight. And when it is above the horizon, it is called sunlight. So that's a simple definition.
Okay, sir.
Okay, let's move ahead. Now in the evening, when the sun sets, till the time sun is there in the sky, we receive the sunlight. Now after the sun has set, we do not have any sunlight. What we receive now is the twilight. The twilight is available to us till the time the sun goes 18 degrees below our horizon. So you can consider this 18 degrees as a negative altitude of the sun. Till the time the sun is within 18 degrees of our horizon, we keep on receiving this twilight, and after the sun crosses this 18 degrees belt, after that there is total darkness and we do not receive any light from the sun. So in the evening time, the twilight commences at sunset and it continues up to the point where the sun is 18 degrees below the horizon, and after that the night starts. So after 18 degrees, there is no light which we receive from the sun. It is totally dark. Now in the morning, the twilight commences when the sun is 18 degrees below our horizon. It reaches at a point when it is 18 degrees below our horizon. That is the period when the twilight starts. Right now, the laser pointer is showing that instant when the sun is 18 degrees below the horizon. We keep on receiving this twilight till sunrise, and as soon as the sun rises, the twilight ceases and we are able to see the sun and receive the sunlight. Now this entire period of 18 degrees is divided into 3 different stages, and we call these 3 different stages as civil twilight, nautical twilight, and astronomical twilight. Now let us see these 3 stages of twilight one by one.
So this twilights end when
go ahead, beta.
this twilight ends when we see the upper limb of sun or when we see the lower limb of the sun?
Beta, if you can see any part of the sun, then it is called sunlight, any part of the sun. When you cannot see any part of the sun, that is the time when the twilight starts or ends. Okay, beta?
Yes, sir. Thank you.
Very good. Let's move ahead. Now we have zoomed into the right side portion of the diagram depicting the sunrise. Now you see the sun is at this instant at a particular time. As the sun approaches towards our horizon, right now it is night, it is totally dark. We are not receiving any light from the sun. Now when the sun reaches at this particular point, you can follow the laser pointer on the screen. When the sun reaches at this particular point, now this point is 18 degrees below the horizon. You can see the angle also mentioned here. The sun has reached 18 degrees below the horizon. Now this is the instant when the astronomical twilight commences. The astronomical twilight has commenced at this particular instant, and we are able to receive some light, though very, very little, at this particular point of time from the sun. After this instant, the sun keeps on coming closer to the horizon, and the altitude is, it was initially minus 18 degrees when the twilight started. Now it starts to come down, minus 17, minus 16, minus 15, and so on. Now at this particular instant, the sun is 12 degrees below the horizon. You can see this angle is 12 degrees now. It is marked in the diagram. Now this is the instant when the sun is 12 degrees below the horizon, and at this particular instant, the nautical twilight commences. The nautical twilight has commenced here. After this instant, the sun keeps on coming closer to the horizon, and at this particular instant, you can follow the laser pointer. At this particular instant, the sun is 6 degrees below the horizon. The angle is shown in the diagram. And at this particular point, when the sun is 6 degrees below the horizon, civil twilight commences. Now, all these three twilights, they go up to the sunrise. Each of them, the astronomical twilight, nautical twilight, and civil twilight, lasts until the visible sunrise. Visible sunrise is when the sun's upper limb appears on our visible horizon. That's the instant we call as visible sunrise. So you see, the commencement time of all the three twilights are different. Astronomical twilight commences when the sun is 18 degrees below the horizon. Nautical twilight commences when the center of the sun is 12 degrees below the horizon. Civil twilight commences when the sun is 6 degrees below the horizon. And all three of them, they last until the visible sunrise, when the upper limb of the sun appears on our visible horizon. So beta, clear up to here?
Yes, sir. When the vessel is in full twilight, it is still in astronomical twilight. You can say that.
That's right, beta.
When it is a full twilight, it is actually in all three twilights, right?
Correct, beta. That's right. Astronomical will continue for all 18. Nautical will continue for all 12 degrees. And civil will continue for 6 degrees.
Yes, sir. Copy that.
Okay.
As soon as sun's upper limb means the
Beta, it basically means that when you can see any part of the sun, the twilight has ended and the day has started.
Any part of the sun, but here they have sent sun's upper limb.
Obviously, beta, upper limb will be the first part which you will see, na?
And when it is setting, that time will be also upper.
That time also it will be the upper limb. That will be the last part which you will see. Right? Right, beta.
Yes,
right. Let's go ahead. Now, out of this entire period, as far as navigators are concerned, as far as sight taking is concerned, which is the most suitable period for us? The most suitable period for us is between 12 degrees and 6 degrees. This particular period, which is represented in blue. The upper period is represented in light blue, and the bottommost period is represented in dark blue. The middle portion is what is important from the point of view of the navigator for the purpose of sight taking. Now this period is basically the commencement of nautical twilight to the commencement of civil twilight. The suitable period for us for sight taking starts at the commencement of nautical twilight in the morning, and it remains up to the commencement of the civil twilight in the morning. Now, why is this period suitable to us? If you go beyond this particular period into the dark blue zone, now in the dark blue zone, the sun is 18 degrees to 12 degrees below the horizon. With the sun more than 12 degrees below the horizon, there is very less light for the horizon to be clear to us. The horizon may not be very much clear to us because the light which we are receiving is very, very, very low. Now, as the sun reaches about 12 degrees below the horizon, we have sufficient light with which the horizon can be clearly seen. And we know for the purpose of sight taking, we need to have the horizon as well as the body in our sight. So we can start our sight taking at this instant when the sun is 12 degrees below the horizon. And this suitable period continues up to the sun going 6 degrees below the horizon. Now, when the sun reaches 6 degrees below the horizon, you see as it is coming closer to the horizon from 18 to 12 and from 12 to 6 now, more and more light is visible to us on the eastern horizon. Now at this particular instant, when it is just 6 degrees below our horizon, there is so much of light on the eastern horizon that stars and other celestial bodies, stars as well as the planet, they start to disappear. So after 6 degrees, we may not be able to easily identify, find out the stars for the purpose of sight taking. It is so bright in the sky that the stars start to disappear. So this period is also not very suitable for us for the purpose of sight taking. The most suitable period is commencement of nautical twilight when the sun is 12 degrees below the horizon to commencement of civil twilight when the sun is 6 degrees below the horizon. So is that clear, beta?
Oh, yes.
Very good, beta. Let's go. Now we have zoomed into the sunset part of the diagram. This is the instant when the sunset takes place. So in the evening, as soon as the sun sets, as soon as we have a visible sunset, which means the sun's upper limb has disappeared from our visible horizon, this is the instant when all the three twilights commence. So the commencement time in the evening for all the three twilights is the visible sunset. The civil twilight continues till the time the sun is 6 degrees below the horizon. At this particular instant, the sun has gone 6 degrees below the horizon. You can see it is represented in the diagram also. Sun is 6 degrees below the horizon, and this is the period when civil twilight ends. The other two continue. The sun goes further down, and when the sun reaches at this particular instant, when it is 12 degrees below the horizon, so sun is at 12 degrees below the horizon here, the nautical twilight ends. Astronomical twilight still continues. The sun also moves down, and when the sun reaches at this particular instant, when it is 18 degrees below the horizon, the astronomical twilight ends. So we can clearly see that all the three twilights begin at the time of visible sunset. Civil twilight continues till the sun is 6 degrees below the horizon. Nautical twilight continues till the time sun is 12 degrees below the horizon. and astronomical twilight continues till the time the sun is 18 degrees below the horizon. After 18 degrees, there is no light received from the sun, and we have total darkness or the night. Now, in this case also, the suitable period for us for the purpose of sight taking is between 6 degrees and 12 degrees, which in this case is the ending of the civil twilight to the ending of the nautical twilight. This is the most suitable period for us. Before this period, the sun is within 0 to 6 degrees of the horizon, and there is too much light for the stars and planet to be visible to us. There is so much light that stars and planet may not be visible. Between 6 to 12 degrees, the light has decreased now. The stars and planets start to appear in the sky. They gain sufficient brightness so that we can observe them by the sextant for the purpose of sight taking. And after this interval, that means when the sun has gone below the horizon more than 12 degrees, there is so less light available from the sun that the horizon is not clear to us. The stars and planets are shining very bright, but the horizon being not visible, it will not be possible to take the sight. So again, the light blue portion is not suitable because there is too much light. The dark blue portion is not suitable because there is too less light for the horizon to be visible. The suitable period for us is the middle period, the blue color period, which is represented by -6 degrees to -12 degrees altitude of the sun. This is the most suitable period in the case of evening twilight. Now, be careful and be clear in your mind that in the morning, the suitable period was commencement of nautical to commencement of civil, whereas in the evening, the suitable period is ending of civil to ending of nautical. Now, practically, if you are trying to take a star sight, you need to be standby on the bridge wing ready with a sextant at this particular instant. That is when the sun is 6 degrees below the horizon. This is the instant when we are ready with the sextant on the bridge wing for the purpose of taking the sight, because this is the beginning of the suitable period for us. If we are ready here, we can observe the horizon also, we can observe the celestial body also, and a sight can be taken. If you are standby at this particular instant, that is ending of the nautical twilight, it will not be of use because the horizon is going to disappear now. So we need to be standby. This is the critical time as far as the evening twilight is concerned. That is the ending of civil twilight. Now, in the case of morning, the beginning of the suitable period is when the nautical twilight commences. Because in the morning, when the sun is coming from below the horizon, it reaches 12 degrees below the horizon. That is where the nautical twilight commences. At that time, the stars are visible in the sky. The horizon also starts to appear and a sight is possible. So the beginning of the suitable period in the morning is commencement of the nautical twilight, and the beginning of the suitable period in the evening is the ending of the civil twilight. So any doubts up to here, beta? Very good, beta. Great. So let's move ahead. Now with this, we finish understanding the concept of number 1, stellar magnitude, then the information given in page 268 of the almanac, the stars information table, and the concept of twilight. With all these three clear in our mind, we can now go into the questions related to stars suitable for observations. Now these questions are divided into different types. This is how they can be asked to us in the examination. We have broken them up into different types, and we will be discussing these types one by one. The type 1 question which comes in the exam, the most basic and the most simplest question related to this topic is that they will ask you which stars will be within a certain R angle of the observer's meridian at a particular given time. So we are now going to see how do we solve this type 1 problem. So beta, these questions I will be showing you through a video. So I'm just closing the presentation. So I'm now jumping into the video. So we will see all these types. There are total 5 types which we have. So going one by one, we will start seeing what are these questions, what in how different ways they can be asked to us, and how each one of them is to be attempted. So let me set up the video.
ये फ्री वाला है या पेड वाला?
We begin by understanding as to how stars are categorized based on brightness, which is expressed through star magnitude that we learned in the earlier video. Now, when we say first magnitude stars, it means stars with magnitude less than 1 or up to equal to 1. Second magnitude stars are the ones which have magnitude greater than 1 but less than or equal to 2. Likewise, magnitude 3, greater than 2, less than or equal to 3 magnitude. You have magnitude 4, magnitude 5, and likewise magnitude 6.
So these are the same categories which we saw in the presentation also. So now we are going into our first question, that is type 1 problem. Which stars will be within a certain R angle of the observer's meridian at a given time? So let's see.
The entire process of star identification based on various needs has been divided into few categories, and we shall see each one of them through some examples. The first one shall be, we shall try and find out the stars which shall be within a certain R angle of the observer's meridian at a given time. Now, on 15th June 1992, in position 20 degrees north, 075 degrees east, which all stars and planets of first and second magnitude will be within 15 degrees of observer's meridian at the end of civil twilight. We shall assume in such cases an imaginary star on the observer's meridian and determine the SHA of that imaginary star. We know that when a body is on the observer's meridian, then its LHA is equal to 000 degrees or 360 degrees. We also know that LHA star is equal to LHA Aries plus SHA of the star. LHA Aries in turn is equal to GHA Aries plus minus observer's longitude. Longitude east, GHA least, longitude west, GHA best. GHA Aries can be obtained from nautical almanac against GMT, Now, if the time in question is given in GMT, it can be directly used. If some other time is given, that needs to be suitably converted to GMT. If the time at all is not mentioned in the question and it is only morning or evening, then for AM cases, we shall use the starting time of the nautical twilight. Please remember, all the twilights begin at different timings in the morning and they all end on sunrise. So we take the time when the nautical twilight begins in the morning. If it happens to be a case of evening, then all twilights will begin on sunset and end at different times, and we shall use the time when the civil twilight comes to an end. The range of SHA acceptable, or for which in which we'll have to find the stars, shall then be calculated by adding and subtracting the range of R angle to the SHA of the star on the observer's meridian. Stars in that range of SHA can easily be then identified for the required magnitude from the star information pages in the Nautical Almanac.
So beta, we will be seeing all these steps now in the question one by one. So all these will be done.
Sir, can you pause this slide for a second? I want to note it down.
Right, beta, I've paused it now. You can see them.
क्वेश्चन भी दिखा दीजिए सर एक बार.
Beta abhi aayega. I'll show you the question. Let me know once you are done, beta. मैं भी बेटा ये आपके साथ शेयर कर दूंगा. ये जितने चीजें आप देख रहे हो ना यहाँ पे, I will share them in a PDF document. So you will have them.
Okay, sir.
Right.
Sir, what is HA here? I missed out. What was HA?
HA is R angle, beta. R angle.
Okay, fine.
R angle. It is a angle measured at the pole, basically between the observer's meridian and a certain meridian that's called LHA. Then if you use a first point of Aries, it is called SHA. If you use Greenwich celestial meridian, it is called GHA. Greenwich R angle, sidereal R angle, local R angle. Okay, so let's go ahead. Let us see the question once again and how to solve it.
Information pages in the Nautical Almanac. Let us now apply the listed step to this question. We need to find out all the stars and planets of first and second magnitude falling within 15 degrees of observer's meridian at the end of civil twilight on 15th June 1992, and the position of the observer is given here in latitude and longitude. Now, to begin with, please note that AM or PM is not stated in the question. It may be stated, may not be stated. But in this case, since it's end of the twilight that is in question.
So now, beta, can you tell me, the question mentions end of the civil twilight. Will it be morning or will it be evening?
Evening, sunset.
Morning.
Evening.
Sunset.
Evening, sir.
Evening, sir, evening.
Very
sir.
good, beta.
Evening.
Very good. Exactly. So it will be the evening time, PM time, because in the morning when the civil twilight ends, that is when the sunrise occurs. So you won't be able to take any sights that time. So it is PM. So good, beta. Let's go ahead.
So the twilights end at different timings in the evening. So by default, it becomes a PM question. Had it been beginning of the twilight, then it would have become a AM question. So now we go to the daily page of the Nautical Almanac for 15th June. For 20 degrees north lat, we pick up the civil twilight time in the evening.
Beta, any doubt you are having in the question? Let me know.
No, sir.
Okay, beta. Great. Let us see the solution then.
And we all know this time shall be LMT. So the LMT of civil twilight in the evening would be 15th day, 19 hours, 05 minutes and 00 seconds. To this we shall apply LIT to get GMT. Longitude is east, so GMT is least. So therefore we subtract this LIT and we get GMT as 15th day, 14 hours, 5 minutes and 00 seconds.
Go ahead, beta.
सर जो टाइम्स दिए एल्मेनाक में ये सब एंड ऑफ द ट्वाइलाइट के हैं
Beta, morning में as we saw in the explanation, these are all beginning times, and evening में as we saw in the explanation, these are all ending times.
ओके सर
Right? Okay, great. So हमने बेटा GMT निकाला है observation के लिए. This GMT we have obtained. Have a look and let me know any doubts coming in up to here.
सर ये नॉटिकल एल्मेनाक में ये टाइम कहाँ से मिला हमें? LMT 15th 19th आवर 05 मिनट्स वाला.
वेरी गुड बेटा. आप कौन सी डेट देख रहे हो इस क्वेश्चन में? कौन से डेट देख रहे हो बेटा आप? विच डे पेज यू हैव ओपन्ड?
15 जून पे हूँ सर.
वेरी गुड. अब बेटा बिल्कुल राइट साइड में आ जाओ एल्मेनाक के. वहां पे कुछ ट्वाइलाइट्स वगैरह दिख रही हैं?
ओके.
सुबह में AM है और इवनिंग में PM है. नीचे की तरफ PM है. Now we want PM civil twilight. So have a look there beta. Latitude 20 degrees north. What is the time given under civil?
सनसेट वाले में देखना भाई.
ओके आ गया सर. दिख गया सर.
ओह वेरी गुड. चले बेटा.
उन लोगों ने अल्मनाक में भी ऐसा अरेंजमेंट करके दिया है that for sunset they have placed civil first and then nautical, and for sunrise they have placed nautical first and civil second.
Exactly. Once you understand the concept, then you know how systematically the things are given in the almanac, right?
Correct, yeah.
सर अगर बीच का वैल्यू रहेगा जैसे 25 डिग्री तो इंटरपोलेट करना पड़ेगा कि
That's right beta. That's right. You will need to interpolate if the latitude is in between.
Okay sir.
Okay beta. Great. Let's go. Time हमें मिल गया है. Let's move ahead.
From the daily pages of the nautical almanac, we extract GHA Aries for this GMT. Now GHA Aries for 15th day, 14 hours is on the screen. To this we add the increment for 5 minutes, 0 seconds, and this gives us the GHA Aries. To this we apply the observer's longitude, that is 75 degrees east, longitude east, GHA least. So we add to get the LHA Aries. So the LHA Aries is 190 degrees, 21.4 minutes.
Okay, we have obtained the LHA Aries now. Any doubt up to here, beta?
No sir.
Very good beta. Let's go.
Now using this LHA Aries, we calculate the SHA of an imaginary star, which is on observer's meridian. And we know that if the star is on observer's meridian, its LHA is 360 and it's equal to LHA Aries plus SHA star. Using the value of this calculated LHA Aries, we get the SHA of this imaginary star to be 169 degrees, 38.6 minutes. And this star is assumed to be on observer's meridian.
Okay, beta. So we have
sir,
obtained.
excuse me, sir. Yes,
Bolo,
sir.
beta. Bolo.
Sir, can you explain in figures in this one LHA star equal to LHA Aries plus SHA star?
Okay.
A pictorial representation.
No problem. No problem. मैं वो भी दिखाऊंगा आपको, पर अभी के लिए बस आप एक चीज याद.
आवाज चली गई. आवाज आपकी आवाज नहीं आ रही.
सर आवाज नहीं आ रही आपकी.
आवाज नहीं आ रही सर. भाई लोग, बाकी सबको आ रही है?
नहीं आ रही यार, आवाज नहीं आ रही सर की।
आवाज नहीं आ रही।
स्मॉल ब्रेक लिया। कि
आवाज नहीं आ रही सर।
वो एक मतलब
साउंड आ रही है क्या?
मेरी आवाज नहीं आती पई यार।
नहीं वो सर का ऑफ हो गया actually।
सर का कर्सर भी नहीं चल रहा है, सर चले गए शायद।
क्या पूछ लिया
अरे
भाई?
लाइट का इश्यू हो सकता है यार, पावर कट हो सकता है।
कुछ तो सवाल पूछा था यार किसी ने, तभी सर चले गए।
भाई इतना कठिन सवाल पूछा कि सर चले गए।
क्या पूछा भाई, क्या पूछा है ऐसा?
छुट्टी होगी भाई, ये छुट्टी।
Beta, I had a bit of disruption, so I hope you can hear me and see me now.
Yes sir.
Yes sir.
Great.
हमें लगा सर आप सवाल का बुरा मान लो।
No problem. So thanks for waiting. That was a network disruption, so I was able to regain the network. Anyway, going back. हाँ, अब बेटा आप बोल रहे थे. Let me be face to face with you. Or let me go back to the presentation. Okay. So beta, always remember one thing. We want to find out GHA of any star, or we want to find out LHA of any star. It is not given in the almanac directly. So for finding that out, what we do is we get the GHA or LHA of Aries. And if we add the SHA to that value, SHA of the particular star, you will get the GHA or LHA of that particular star. This is basically the function of SHA, sidereal R angle. Once it is applied to Aries, it gives you the corresponding value for that particular star. So अभी के लिए आप इतना याद रखो. Later on I will be making a rational horizon diagram. मैं वहां भी आपको explain कर दूंगा. Right बेटा?
Okay sir, thank you.
सर ये जो सामने लिखा हुआ है LHA स्टार इक्वल्स टू LHA एरीज प्लस SHA स्टार,
राइट?
फॉर्मूला सर वो नहीं होता था LHA इक्वल्स टू GHA प्लस लॉन्जिट्यूड, फिर GHA इक्वल्स टू GHA एरीज प्लस SHA स्टार?
That's okay बेटा. अगर आप वो फॉर्मूला भी लगा दोगे तो when you apply GHA Aries plus minus longitude, it will become LHA Aries ना?
Okay.
You can use that formula also. No issues.
Okay sir, वो एक ही बात है मतलब आगे.
मेरिडियन पे इसलिए.
Exactly. एक ही बात है बेटा. आप वो फॉर्मूला चाहो तो वो भी लगा सकते हो. You will get the same answer.
Okay sir.
Okay. Okay beta. Great. So everybody okay up to here? Can we move ahead?
Yes sir.
Very good बेटा. So basically बेटा हमने क्या निकाला है? हमारे पास SHA आ गया है एक ऐसे स्टार का which is a imaginary star and it is on the observer's meridian. हमारे मेरिडियन पे इस पर्टिकुलर टाइम पे कोई भी स्टार अगर है तो स्टार का SHA 169.38.6 मिनट्स होगा. सो ये हमें पता चल गया है. आप इसको ऐसे भी कंसिडर कर सकते हो that the SHA of our meridian is 169.38.6. हमारे मेरिडियन का अगर SHA निकाला जाए तो it is 169.38.6. It is one and the same thing. Whether you say SHA of a star on my meridian is this much or you say SHA of my meridian is this much. So ये हमने ढूंढ लिया है. Now we are moving ahead from here. Let's go.
सुनाई नहीं दे रहा सर.
आवाज नहीं आ रही सर.
Sound is not coming, sir.
Okay, beta. Sound is not coming. Just a minute. I will disconnect and connect again.
Okay, sir.
Star. Using the value of this calculated LHA Aries, we get the SHA of this imaginary star.
Is the sound coming now, beta?
Yes, sir. Now it's okay.
Very good. Very good. So I've rewinded it. We just stopped here, moving ahead from here now.
To be 169 degrees, 38.6 minutes. And this star is assumed to be on observer's meridian. Now we have to find all the stars which lie within 15 degrees of observer's meridian. That means 15 degrees of this SHA. So by subtracting 15 degrees from here and adding 15 degrees to this, we find out the applicable SHA range. The SHA range within 15 degrees of observer's meridian would be 154 degrees, 38.6 minutes to 184 degrees, 38.6 minutes. That means all the stars and planets with within this SHA range shall be within 15 degrees of observer's meridian.
Okay, beta. Let me now explain this to you. हमने सबसे पहले ये SHA निकाला एक imaginary star का जो हमारे meridian पे है. That came out to be 169. Now what we did was इस 169 में हमने 15 degrees add किया और subtract किया. We got a value of 154 to 184. So this range basically tells us the SHA of any star falling within this range. That particular star will be within 15 degrees of our meridian, or it will be within 15 degrees of our angle from the observer's meridian. So is it clear, beta, up to here?
Clear, sir, clear.
Great, beta, great. So once we have found this range, now it is simple. We have to go to the stars table and get the stars out. So you can also open up the stars table and you can keep on following. So let me show you the stars which are coming in this range now.
Now we go to the daily pages. Sorry, we go to the table for stars. Now, if we go to the table for stars in the Nautical Almanac, we know that this information is tabulated in the ascending order of the SHA. We identify this range that we have calculated, and we see that this is the range which is in question here. Now, in this range, we find out the stars of first and second magnitude. Magnitude is in the first column. So we identify there is one star here of magnitude 1.2. Then there are two stars out here, one of 1.7 magnitude, another of 1.5. Then two more here, 1.6 and 1.1 magnitude respectively. In this range, we find these are the only 5 stars which belong to first and second magnitude. So these are the 5 stars. Now these are the Latin names of these stars. On the opposite page, we can have their English names. Their SHA can be picked up from here for the month of June, and so is their declination. And we can tabulate these stars then. Stars of first and second magnitude within 15 degrees of our angle of the observer's meridian. And these stars with English names are then Spica, Elliott, Mimosa, Gacrux, and Acrux, together with their SHAs and declination. Now for this planets, we go to the daily page of the Nautical Almanac for 15th June.
Okay, beta, now you can go to this page number 270 and you can find out the stars within this range. You have the range in front of you. Just go there and try to identify these stars. Are you able to identify them? If any doubt is coming, please share with me, beta.
Done, sir. Identified.
So what is the meaning of first and second magnitude? 2 point and all, 1 point and all comes under first and second.
No, beta, I didn't get you. Can you repeat again, please?
Sir, what is the meaning of this first and second magnitude? This 1.1, 1.3, 2.3 and all comes in first and second, right?
बेटा एक टेबल दिखाया था ना पीपीटी में भी और इस वीडियो में भी stars having magnitude equal to or less than 1.0 are called first magnitude.
Okay, sir, got it.
Okay, so basically अगर हम इस क्वेश्चन की रिक्वायरमेंट देखें, any star having a magnitude of 2.0 or lesser should be included in our list.
Yes, sir, got it.
Right?
Okay. SHA स्टार रेंज के लिए SHA स्टार है सर, और SHA स्टार के लिए हमने टाइम लिया सिविल ट्वेलाइट का एंड होने का सर.
That's right, बेटा.
बट जो अपन क्या साइट लेंगे वो तो पूरा एक रेंज हो रहा है सर, फ्रॉम 6 डिग्री टू 12 डिग्री, तो पूरा टाइम अलग होगा सर.
एग्जैक्टली बेटा, बिल्कुल सही है. मैं समझ गया आपका क्वेश्चन. साइट लेने के लिए हमारे पास 15 मिनट 20 मिनट 30 मिनट का इंटरवल हो सकता है, लेकिन हर एक मिनट में बेटा कुछ स्टार 15 डिग्री के अंदर आ जाएंगे, कुछ उससे बाहर चले जाएंगे. सो हमें तो एक पर्टिकुलर इंस्टेंट जो क्वेश्चन में दिया गया है उसी पे इसको चेक करना है. उन्होंने हमें एक इंस्टेंट दिया, एंड ऑफ सिविल ट्वाइलाइट, हमने उस पे चेक कर लिया.
ओके सर, अगर वो सूटेबल बोलता है तो फिर तो पूरा रेंज आता है सर, करेक्ट?
सूटेबल फॉर मैं बताऊंगा बेटा आपको धीरे धीरे आगे. सूटेबल फॉर साइट वाले क्वेश्चन भी आएंगे. आई विल टेल यू, डोंट वरी.
ओके ओके सर, थैंक यू.
एक्सक्यूज मी सर.
बोलो बेटा.
सर ये जो टेबल बना है वो मैग्नीट्यूड की बेस पे बनाएंगे या एसएचए के बेस पे बनाएंगे, एसएचए के रेंज की बेस पे?
ओके बेटा, ये जो टेबल है ये स्टार्स की जो सिलेक्शन होगी वो होगी मैग्नीट्यूड के बेस पे. हम लोग 2.0 से छोटे मैग्नीट्यूड वाले सारे स्टार को पिक करेंगे और उनको इस टेबल में लिखेंगे. कैसे? सबसे पहले सबसे कम SHA और फिर उसके बाद उससे ज्यादा एंड देन मैक्सिमम SHA. ऐसे हमने इसको टेबल में डाला है.
थैंक यू
सर. ये टेबल लिख ले हम लोग 1 मिनट में.
यस बेटा, यू कैन. हाँ बेटा, आप बना सकते हो. मैं भी आपको PDF में ये डिटेल्स भेज दूंगा. आप अभी बनाना चाहते हो आप अभी बना सकते हो.
सर ये स्टार नंबर भी लिखना मैंडेटरी है क्या? स्टार नंबर
दैट इज द ओनली थिंग व्हिच इज नॉट मैंडेटरी. आप चाहो तो ये स्टार नंबर को छोड़ सकते हो. इसको छोड़ के बाकी सारी चीजें आपने लिखनी है बेटा. मैग्नीट्यूड, नेम, SHA, डेक्लिनेशन.
Sir, one down.
बोलो बेटा.
So if you see this left side, exactly Ursa Major, that is Alkite, is also coming very close. So it can be considered or not?
Beta, is it within the range? See, the range is clear. 154.38.6 to 184.38.6. Just see, is the SHA within the range?
No, sir, it's coming 153 something. So it's hardly 1 degree difference. But it will be visible, right?
Yeah, it will be visible, but it will not be within 15 degrees of the observer meridian.
Okay, correct.
It may be visible, but it is not falling in our criteria, so that's why we did not write it in our answer.
सर इसमें ऐसे कोई सिचुएशन बन सकती है क्या हमें जहाँ पे SHA को इंटरपोलेट भी करना पड़ जाए किसी स्टार की?
No beta, no. You will not need to interpolate the SHA. Not required.
Okay.
Are we expected to get like this kind of question? ये तो basic था.
Say again, beta.
Are we expecting like this kind of question in exam?
Certainly, beta. Number 7 इसी type का question आता है most of the time.
सर हो गया लिखना.
Great बेटा, excellent. So ये सबसे बेसिक क्वेश्चन था बेटा. अब हम धीरे धीरे जो है अपना अंडरस्टैंडिंग बढ़ाते चले जाएंगे. So let us now move to the second part.
सर मुझे एक चीज समझ में नहीं आया, ये नीचे है ना, there are no planets within SHA in the given range, ये कैसे पता चलेगा सर?
Very good बेटा. अभी आप ध्यान से सुनना. अभी मैं बताता हूँ planets कैसे पता चलेंगे.
Okay sir.
Calculate these stars then. Stars of first and second magnitude. If any of the 4 planets listed there have their SHA in this range, we find that none of the 4 planets have the SHA. Nautical Almanac for 15th June. On the left side, right bottom corner, we have the information for the planets. We see if any of the 4 planets listed there have their SHA in this range. We find that none of the 4 planets have the SHA falling in this range. Therefore, there are no planets with SHA in the given range or within 15 degrees of observer's meridian as required by this question.
So beta, you go to the daily page and check the SHA of planets. It is given there at the bottom right corner of the left page. Have a look on 15th June.
Yeah, okay sir, I already checked. Thank you sir.
Very good beta. Great. चलें आगे. Let's go.
So we have only these 5 stars and no planet. I hope this question is well understood. If not, please pause the video, go back by 5 minutes and revisit this particular part before moving with the other type of questions, because this will form the basis of practically all the questions. We just learned to make a list of stars and planets which meet the requirement of given magnitude and which also lie within the given range of observer's meridian. Now, all these stars that we identified may be visible to the observer, may not be visible, may be suitable for taking sights, may not be suitable. So now next we'll try and assess their visibility criteria and also their suitability for taking sights. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be visible to the observer and suitable for taking sight. I'm sure you'll agree with me that first step shall be to make a comprehensive list of all stars and planets which meet the given requirement of magnitude and hour angle. Now, to assess visibility, we know that the body must be above the observer's rational horizon. We also know that for a body to be above the rational horizon, for whatever period of the day it may be, a latitude of the observer and declination of the body, if they are same names, yes, body would definitely be coming above the horizon for some part of the day. Or if they have opposite names, then the body shall be above the rational horizon only if the sum of latitude and declination is less than 90 degrees. Now, both these things can be summed up in one condition, wherein we say we find out the L difference D, difference between latitude and declination, and if the difference is less than 90 degrees, the body shall be visible. What do we mean by L difference D here? Please note, it means we are talking of algebraic difference between latitude and declination, and algebraic difference means that if they are same names, you subtract, and if they are opposite names, you add. And if the algebraic difference is less than 90 degrees, the body shall be above the rational horizon and hence visible.
Okay, beta. So this is what we will be doing. You need to note the condition for a body to be above the observer's rational horizon. कोई भी body ऑब्जर्वर की हॉराइजन से तब ऊपर होती है when the L difference D is less than 90 degrees. इस कंडीशन को बेटा आपको याद रखना है. So please mark this L difference D less than 90 for a body to be above the horizon or visible. ये स्टेप्स मैं अभी आपको करके दिखाऊंगा बेटा क्वेश्चन में. So shall we move on?
Yes, sir.
Very good.
So now we can close out this question. First, we have the comprehensive list of all stars and planets meeting the magnitude and hour angle requirement.
Beta, you can give a reading to the question, and if there is any doubt, please share with me.
Can I go one slide back? Just wanted to add.
Okay, one slide.
ये तो वही हो जाएगा ना जो हमने पिछला वाला निकाला है visible to observer.
Exactly, beta. The first part of the question is exactly same. Only addition is we have to find the stars which will be visible and which will be suitable for sight. ये दो चीजें ऐड हुई हैं. बाकी question exactly same है which we did last.
Okay.
Okay. So going to the previous slide. Here it is, beta. Let me know once you are done.
Yeah, thank you.
Okay. So moving on to the solution now. Give me a minute, beta. There is some issue with the player.
Hello, welcome to meridian that for to find L difference D for the rational horizon and hence visible. So now we can close out this question. First, we have the comprehensive list of all stars and planets meeting the magnitude and hour angle requirement.
Is the audio video working well, beta?
Yes, sir.
Okay. Okay, beta.
Which I'm sure all of us would agree is the same as the result of question number 1. So we pick up the result of stars from earlier working and now assess whether they are going to be visible or not. These are the 5 stars which meet the requirement of magnitude and the hour angle as far as this question is concerned. Now to assess visibility, we have just learned we have to get L difference D. So we insert one more column here for observer's latitude, and observer's latitude is 20 degrees north. Now we have to find L difference D before we show it up. Just to reiterate, L difference D means algebraic difference. Same names subtract, opposite names add. And now we have L difference D showing up here. Opposite names add, same names subtract, and we have L difference D for all the 5 stars in this column.
You can have a look at the L difference D, beta. Let me know if any doubts come in.
Opposite names?
Opposite names to be added, same name subtract, smaller one from bigger one.
Same like D long, sir.
Exactly, beta. Okay, beta, great. So let's move ahead.
Now, for the star to be visible, this L difference D shall be less than 90 degrees. And we see that for all the 5 stars, for all the 5 cases here, L difference D is less than 90. Therefore, all these 5 stars shall be visible to the observer.
So clear, beta?
Yes, sir.
Very good, beta. Let's move ahead. Let's move to part B of the question.
Sir, 1 minute.
Okay, holding.
Sir, in exam we have to make table like this only, same.
बिल्कुल बेटा, हमें ऐसा ही टेबल बनाना है और उसमें ये चीजें शो करनी है.
Okay, sir.
Sir, what if the L difference D will be exactly 90 then?
That comes in a just touch and go case, because if L difference D is exactly equal to 90, it tells you that the stars will be just touching your horizon and then again going down. So if you want, you can include that. The examiner you will have the benefit of doubt. So if it exactly comes equal to 90, though it is very, very rare that it will happen. But if you get such a case, you can include that in the list.
Okay, sir. Thank you.
Okay, chale beta, part B.
Sir, same name, declination, latitude, same name we have to add, right?
No beta, same name to be subtracted, opposite names to be added.
Okay, sir. Thank you.
Okay, great. Let's go.
Now, yes, they are visible to the observer. Are they suitable for taking sight or not? For a star to be suitable for sight, obviously it has to be above the horizon and visible, otherwise sight cannot be taken. And 2, there should be some minimum altitude, and we have put a cap of 10 degrees. So it must have altitude of more than 10 degrees. Now for if the altitude has to be more than 10 degrees, this L difference D has to be less than 80. So to assess the suitability for sight, we can make one more column and see in which all cases L difference D is less than 80. And we see that for first 4 stars, they are all suitable for taking sight. The last, that is Acrux, though it is visible, but it's too low and is not suitable for sight. So I hope you will remember this requirement to assess the suitability for taking sight, and also the conditions required for a star or celestial body to be visible to an observer.
So you see beta
Sir,
for
can you
part
explain the last point, sir, regarding the altitude? Why you take why you say this allow to altitude?
beta, can you repeat the question, please?
So why the cap of 10 last point, altitude above 10 degree, for which L and D less than 80.
Okay, so you mean to say why less than 10 degree should not be used for a sight, right?
Yes, sir. It's a true altitude, sir. For example, from our body to the rational horizon. That one.
That's right, beta. It is the true altitude. I'll just tell you that. अभी बताता हूँ मैं आपको. But पहले बेटा जो condition है, the stars which are suitable for taking sight should fulfill the condition or criteria L difference D less than 80. Once they fulfill this criteria, we know that the stars are above 10 degree altitude, and above 10 degree altitude, these will be suitable for sight. So this was the question. Now beta, coming to your question, just a minute. Okay. Now you want to know that why a star with altitude less than 10 degrees should not be used for sight, correct?
Yes, sir.
हाँ, अब इसके लिए काम करो बेटा, just open the first page of your almanac.
sir.
Opened. You have total correction for sun and stars and planets. देखो ये टेबल कहाँ से शुरू हो रहा है? Which value is it starting?
Sir, 9
Exactly. So 0 to 9 के लिए values यहाँ नहीं दी गई हैं, correct?
Yes, sir.
So that basically explains you why 0 to 10 should not be taken. It is not there in the table also, right, beta?
Yes, sir. So, but sir, it is showing apparent altitude, sir. It is true, all right?
It's not a very hard and fast cutoff point, beta. Whether you take apparent altitude or true altitude, both are fine. Basically, the altitude should be roughly above 10 degrees for it to be suitable for sight. Okay.
Yes, sir. So actually, sir, I understand this, sir. Actually, if you explain in a pictorial representation, it will be more easy.
No, picture not required, beta. I will tell you the reason for that also. अब आपने टेबल देख लिया. That table is starting from 9 degrees and some minutes. Correct? Now, what is the reason? Yes. Why is the table starting from that value? The reason is when a star is at a very low altitude, means less than 10 degrees, at that time, number one, the refraction error is very, very high. Refraction error in altitude correction, we did a refraction error. Refraction error is very, very high that time. And number two, the refraction error changes very, very fast. Means if there is only, let us say, 1 minute change in the altitude, the error also changes very fast. So because of that, when you are doing the altitude correction, a slight error in finding the altitude of a body will lead to a big error in your answers. That is why a altitude of less than 10 degree not recommended. Were you able to understand?
Yes, sir.
Very good, beta. Great. Oh, is it clear now? Shall we go back to the solution?
Yes, sir.
Very good. Going back, beta. Okay, so we are back at the solution. Any more doubt coming to your mind? You can have a look and ask me, beta. Great. So I hope it is clear up to here. हमने visibility and suitability for sight, these two conditions we have seen, and now we can move ahead. Shall we?
Yes, sir.
Okay, beta. Great. Let's go.
Another type of question that is asked in the exam is to figure out or find the stars and planets which are suitable for X meridian observations. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be suitable for X meridian observation.
Okay, beta. So this is the next question which we have now. It is basically a add-on to the first question only. If you see, the first part of the question is exactly same. So we will get the same 5 stars which we obtained earlier. The only extra thing this question asks is that out of these 5 stars, which one of them will be suitable for X meridian observation? This is the only new thing which is there in this particular question. Now, beta, tell me one thing. To find whether a star is suitable for X meridian or not, हमें क्या पता करना पड़ता है बेटा? What do we need to find out?
Limit, sir. Meridian.
X meridian limit.
Exactly. Very good, beta. So we have to check whether the star is within the X meridian limit or not. तो हमें दो चीजें चेक करनी पड़ेंगी. एक तो हमें ये चेक करना पड़ेगा कि इन पांचों स्टार में से हर एक स्टार की लिमिट क्या है. Every star will have a different limit because it will have a different declination. Limit is picked up from X meridian table. We have seen the X meridian table. We enter into table 1, we get factor A. Then with factor A, we enter into table 4 and table 4 gives us the limit. So we have to check the limit for each and every star. This is one thing which we need to do. दूसरी चीज जो हमें करनी है, second thing which we need to do is we need to find out how much far away from the meridian that particular star is. हमें ये ढूंढना पड़ेगा. Now for that we need to know what is the rate at which stars cover the R angle. So do you remember beta, stars cover their R angle at what rate? How many degrees per hour?
15 डिग्री पर
14 डिग्री
से थोड़ा कम था सर, 14 डिग्री समथिंग.
वेरी गुड. सो अभी हमें डाउट आ गया है. अब इसको कैसे क्लियर करें? Go to the increment table of the almanac. You have the almanac with you. Open up the increment table. Check the increment for Aries. Aries is what refers to stars for 1 hour. What is the increment of Aries for 1 hour? Please tell me.
Oh, 15 minutes.
0.2 minutes. Sorry, sir. Sorry.
So it is increasing gradually.
About 15 minutes.
15 degrees, sir. 15 degrees.
बेटा अभी तक ना 5 आंसर मिले, पांचों के पांचों गलत हैं. ट्राई अगेन. जाओ एल्मनैक में 1 घंटे का इंक्रीमेंट देखो. एरीज
15 डिग्री 2.5 मिनट्स.
वेरी गुड बेटा, मिल गया हमें फाइनली. बेटा 0.2 मिनट नहीं है, 15 डिग्रीज 2.5 मिनट्स है. फिफ्टीन डिग्रीज 2.5 मिनट है एरीज का इंक्रीमेंट फॉर 1 आवर.
हाँ सर.
एवरीबॉडी गॉट इट नाउ?
1 आवर का बता दिया सर, मिनट्स में है ना, मिनट्स पर सेकंड.
15 degrees 2.5 minutes per hour, or in 1 hour. This is how much R angle the stars cover. This basically tells you the speed at which the stars move in the sky. In 1 hour they cover a R angle of 15 degrees 2.5 minute. So now you tell me, अगर कोई स्टार आपके
मिनट और सेकंड में दिया है ना
बेटा, इंक्रीमेंट टेबल में there are no seconds. ध्यान से देखो, मिले कोई सेकंड है वहां पे?
भाई डेली पेजेस में जहाँ जीएमटी टाइम वगैरह जहाँ लिखा है उसमें बोल रहे हैं सर. जीएचए ऑफ एरीज में देख लेना कितना डिफरेंस आ रहा है दोनों में.
नहीं बेटा, मैं इंक्रीमेंट टेबल में बोल रहा हूँ. इंक्रीमेंट टेबल ऑफ द नॉटिकल एल्मनैक.
59 मिनट्स लेके 60 मिनट का बीच का डिफरेंस देखो ना. 00 मिनट्स लेके 60 मिनट का डिफरेंस देखो.
अरे कुछ भी नहीं देखना भाई. जो एल्मनैक का सेकंड लास्ट पेज है जहाँ पे सबसे ऊपर 59 मिनट्स लिखा हुआ है, उसके अंदर सबसे नीचे आके एरीज के नीचे देखो क्या लिखा हुआ है, 15:2.5. वही मतलब 0 से लेकर 60 मिनट मतलब 60 मिनट का डिफरेंस यहाँ लिखा हुआ है. जहाँ पे 59 मिनट लिखा हुआ उसमें नीचे देखो. मैं फोटो भेज देता हूँ ग्रुप में.
ओके यार, थैंक यू.
मत भेजो बेटा फोटो, देखने दो, एग्जाम में दिक्कत हो जाएगी. ओके सो मिल गया बेटा, एवरीबॉडी गॉट इट. स्टार्स का जो 1 घंटे का इंक्रीमेंट है दैट इज 59 मिनट 60 सेकेंड, दैट इज 15 डिग्री 2.5 मिनट. मिल गया?
यस सर.
ओके, अब इसके साथ ही 2 और फंडे भी क्लियर कर लो, नहीं तो ओरल्स में गड़बड़ हो जाएगी. इफ समबडी आस्क्स यू, टेल मी व्हाट इज द रेट एट विच द सन मूव्स?
15
डिग्री.
Very good. Exactly 15 degrees per hour. This is the increment of sun's GHA in 1 hour. So sun travels at a rate of 15 degrees per hour. All the stars, they travel at a rate of 15 degrees 2.5 minutes per hour. Now tell me what is the rate at which moon travels?
14 degrees 19 minutes.
19.0.
Where is it?
14 degrees 19 minutes.
Great. 14 degree 19 minutes is what is given in the table. You remember moon में V correction भी लगती है बेटा?
Yes sir.
Yes.
उनके GHA निकालने के टाइम V correction भी लगती है. So it is 14 degree 19 minutes plus the V correction of moon for that day and hour. Right, beta?
Correct.
Moon does not move with a fixed speed. Moon speed keeps on changing. Every day, every hour, there can be a little bit of change. So 14 degree 19 minutes plus the V correction gives you the rate at which the moon changes its hour angle. Right, beta? Everybody got it?
Yes, sir.
Okay, sir.
Very good, beta. Great. Now, one more thing I'll add on. For planets also, it is exactly same. Planets fall under the column of sun. You see, sun and planets के लिए एक ही column है. तो उनका जो base value है वो तो 15 डिग्री है, 15 degrees. Plus and minus जो भी V correction होगी planet की for that particular day, it has to be applied to those 15 degrees to get the rate at which a planet moves. Okay?
Yes, sir.
Sir, I think the rate at which the planet moves at the given time, and I mean at the GMT, right? Total.
Yeah, at any given time, beta, any GMT day, hour and minute or day and hour, the rate at which the planet moves will be 15 degrees plus or minus its V correction for that day.
Okay.
Okay, great. Now we are ready to go into the question. So going back, beta, now I'm showing you the screen again. So we have the question now on the screen. We have to find out star suitable for X meridian. Let's see.
I'm sure you can see that the first part of the question is same as has been solved earlier. It's only that now we have to figure out as to which of those stars shall be suitable for X meridian observation. We know every visible star or planet need not be suitable for X meridian observation. To check if a star is suitable for X meridian observation, we need to obtain R angle P, which is the difference in the SHA of the star or the SHA of the planet in question and the SHA of an imaginary star on the observer's meridian. We had already learned how to calculate the SHA of an imaginary star on observer's meridian by equating the LHA to 360. So P is the difference between the SHA of this imaginary star on observer's meridian and the SHA of the star or SHA of the planet in question. Then we obtain the time to Marpas, the body is yet to cross the meridian, or the time from Marpas or since Marpas if the body has already crossed the meridian. And how do we get this time? We get this time by dividing this R angle P by 15 degrees 02.5 minutes. This will come in hours. We multiply by 60 to get this time in minutes. What is this 15 degrees 02.5 minutes? It's the rate of change of R angle for stars and planets. What is this rate for sun? We know the rate of change of R angle for sun is 15 degrees per hour and it's 15 degrees 02.5 minutes for stars and planets. Then we use any of the nautical tables and from there we find the X meridian limits applicable to this case, which will depend on the observer's latitude and the declination of the body. So we get the X meridian limits from nautical tables. If the time to Marpas or time from Marpas calculated above is within the X meridian limits obtained from the nautical tables, then the star is suitable for X meridian observation. Otherwise, it is not suitable for X meridian observation.
So beta, I will be explaining you these steps now when we solve the question. So I'll tell you what is the meaning of each and every step. So shall we proceed to the solution?
Yes, sir. Proceed.
Okay, all right.
One of the X meridian limit table is as shown here on the screen, wherein you can use them with declination of the body and the observer's latitude, different tables for same and contrary names.
Now this is Burton's table, beta. We are not using Burton's. We are using Norris tables. So we will use Norris tables only. X meridian table 1 and 4.
However, you are likely to have different methods of obtaining X meridian limits based on the nautical tables that you use. So please familiarize with the process of obtaining X meridian limits from the nautical tables that you use. Each nautical table may have slight difference in the process and also in the values, because these values are approximate values. So there will be also a slight variance in the values, which is insignificant. You can go by the values that you get from your tables. Now we are in a position to close out this question. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be suitable for X meridian observation? I'm sure we'll agree that first part of making a comprehensive list of stars meeting the magnitude and R angle requirement, we have already done. It's the same question as the earlier ones. So we'll bring forward the same list that we made in the earlier questions. We know these are the 5 stars which meet the requirements of magnitude and the R angle. Of these, Acrux is not suitable because of its low altitude. Now we'll assess their suitability for X meridian observation. Of course, we'll not be doing so for Acrux because since it's not suitable for sight, so gauging its suitability for X meridian would not be of any value. So to get the to assess the suitability for X meridian observation, we need to get angle P. So for which we need to recall the value of SHA of the imaginary star on observer's meridian, which was obtained in the first question, and that value was 169 degrees 38.6 minutes. So SHA of the imaginary star on meridian would be so much. SHA of the respective star is as tabulated here. The difference between these two for respective stars shall give us the R angle P. So this R angle P for Spica is the difference between 169 degrees 38.6 minutes and 158 degrees 47.7 minutes. Likewise, we have got the R angle for all the stars.
Okay, beta. Now let me pause and explain this to you. Now you see this SHA on the meridian 169.38.6 is basically the SHA of the observer's meridian. Observer meridian SHA is 169.38.6. The SHA of star Spica is 158.47.7. So for star Spica to come on the observer's meridian, it will have to cover a R angle of 10 degrees 50.9 minutes. That is what we have written here in the R angle or P column. R angle is also known as angle P. So is this clear, beta? How did we get this R angle?
Sir, SHA on observer meridian I missed out.
Yes, sir,
Can you find out 169.38.6? Can you repeat?
Okay, beta, I will show you. If you go back to the first question, तो हमने SHA of the star on our meridian ये सबसे पहली चीज निकाली थी बेटा, जिसमें प्लस और माइनस 15 किए थे, ये वही SHA है.
Okay, sir. Sorry. Now I got it.
Okay.
For the star Mimosa, the SHA is not on the daily pages. Where do we get this?
Star Mimosa, the SHA is not on daily pages. We are not going to daily pages, beta. We are going to table given on page 268.
Okay, sir.
So just go to table given on page 268. Go for SHA 168. You will find Mimosa there. So up to here, everybody is clear, beta. Shall we move ahead?
Yes, sir.
Very good, beta. So we now know Spica is 10 degrees 50.9 minutes away from my meridian. Elliot is 3 degrees 4.5 minutes away from my meridian. Mimosa is only 1 degree 28.3 minutes away. and Gekrux is 2 degrees 39.8 minutes away from my meridian. Let's move ahead now.
Next we get is the time to Marpas or time from Marpas by dividing this R angle by 15 degrees 02.5 minutes. When we divide, we get time to or from Marpas as shown here. This is 43 minutes 16 seconds, and we have time for other stars also.
So pay attention now, beta. Spica star was 10 degrees 50.9 minutes away from my meridian. I know it moves at a rate of 15 degrees 2.5 minutes per hour. So if I divide this R angle by 15 2.5, I will get the time which Spica is going to take to come on my meridian. This comes to 43 minutes and 16 seconds. So if you want, you can punch in these numbers in the calculator and see if you get the time correct.
इससे बोलिए सर P क्या है सर? Can you define this so that we can imagine?
Yes, beta, sir, P is basically the R angle which the star has to cover to come on the meridian. You see, Spica is at 158 SHA. To come on my meridian, it has to come at 169 SHA. 169 SHA is the SHA on my meridian. So it has to cover 10 degrees 50.9. It is the difference between these two to come on my meridian. How much time it is going to take? Just divide it by 15 2.5, you get 43 minutes and 16 seconds.
So earlier you mentioned that value to be multiplied by 60. What is the need of that?
Not required, beta. Scientific calculator, as you divide by 15 2.5, you will get the answer straight.
Yeah, correct, exactly. That's because the previous slide you mentioned.
So is it? Beta, speak again slowly once more.
को किससे डिवाइड किया सर टाइम निकालने के लिए?
Beta, the speed at which the stars move, which is 15 degrees 2.5, उससे divide किया है P को.
Okay sir, copy that.
Okay, so if you are comfortable, आगे चलें बेटा.
Yes.
Very good. Let's go.
Now we use nautical tables and get the X meridian limits using the nautical tables. We have used the Norris tables to get the X meridian limits. So these X meridian limits are as per the Norris table: 29 minutes for Spica, 44 minutes for Elliott, and the others as listed.
Now we know better how to get the X meridian limit using the declination and latitude. So using these two, we get these limits from the Norris table, X meridian tables. I hope everybody. बोलो बेटा.
ये X meridian limits कैसे निकाला ये एक बार brief में कर देंगे सर आप please.
बेटा, you remember हमने जब X meridian site की थी, we calculated the X meridian limit. We went to table number 1 जिसमें एक latitude और declination दिया हुआ था. We put out. एक बार दोबारा.
हाँ सर, just सर शो कर दीजिए एक बार.
ओके, तो मुझे अभी शो कर देते हैं बेटा. एक बार इसको कंप्लीट कर लेने तो then we go to the X meridian limits. Okay. You have the tables with you बेटा. You have the tables with you. Just open it up. We will अभी करते हैं बेटा. ये लो. Great. Go to table number 1 बेटा. Table number 1 में जाओ.
Okay.
Now table number 1, we have a latitude of 20 degrees north. So look for 20 degrees north latitude. Go to that part of the table which shows lat and dec opposite names.
Or 2.09.
Very good. So आपको मिल गया वो पेज lat and dec opposite name.
Yes, sir. Page number 406. No
Very
response.
good, beta.
405
Latitude, it's okay. Latitude is 20 north and declination is 11. So latitude 20, declination 11. Opposite names में देखो बेटा, फैक्टर ए की वैल्यू क्या आ रही है?
3.52 आ रही है.
Yes, sir. 3.52. मैंने 21 declination ले लिया.
Very good. 3.52 आ रही है. Now go to table.
Table number 1.
Not required, beta. You go to the nearest degree.
अरे भाई ये टेबल नंबर 1 कौन से पेज नंबर पे है?
पेज नंबर 405 पे चला जा भाई सीधा.
ओके.
So 3.52 is what everybody is getting. Now beta, with this 3.52, go to table 4. X meridian table 4. वहां पे देखो 3.52 के आगे क्या लिखा है बेटा?
3.5 के आगे 29 लिखा है.
Exactly beta. So nearest value is 3.5, you get 29. That's why you see 29 as a X meridian limit here.
Sir, X meridian table 4 या 3?
4 बेटा, 4.
सर ये 1 के भी 2 पेजेस है ना सर?
बिल्कुल 2 हैं जी. एक में लेट इंडेक्स सेम नेम है, दूसरे में ऑपोजिट नेम है.
हाँ सर, ओके ओके.
So for second one, we'll have to use same name, right? Same lat name.
Exactly beta. For second star, that is Elliot, you will have to use let index same name because they are same, both are north.
Correct.
One
So
doubt, sir.
this-
Table 2 और 3 का भी use कर सकते हैं when we are using 2 and 3 table?
ये डाउट तब क्लियर किया था when we did X meridian site. I'll clear it again now. Table 2 and 3 were used when we did not have calculators. Now we have calculators. We don't use table 2 and 3 at all.
सर मुझे नहीं मिला सर, एक बार और बता दो सर. लैटिट्यूड 20 डिग्री है ना, उसके बाद सर डिक्लिनेशन 11 डिग्री 7.5.
That's right beta. Go to table 1 and look for these values.
है 7.5 तो इसमें है, ये 7.43 है.
भाई लैटिट्यूड 20 नॉर्थ है और डेक्लिनेशन 11 साउथ है. ये 20 और 11 का कॉम्बिनेशन मिल रहा है.
हाँ सर, 20 और 11 का तो मिल रहा है.
वेरी गुड, मिल गया. अब देखो बेटा, ऊपर लेट एंड डेक ऑपोजिट नेम लिखा है.
हाँ सर लिखा है.
ओके, तो क्या वैल्यू आई बेटा 20 और 11 के बीच में?
3.52.
वेरी गुड. अब इसको माइंड में रखो और टेबल 4 में चले जाओ.
ओके सर.
और देखो टेबल 4 में 3.52 के नियरेस्ट वैल्यू क्या आ रही है?
टेबल 4.
बहुत लेंथी क्वेश्चन है सर ये.
3.5 है, 29.
वेरी गुड बेटा. ये 29 ऊपर लिखा हुआ मिल गया.
ओके सर, गॉट इट. थैंक यू.
गॉट इट. अब ये बेटा जितने लोगों के डाउट आए हैं ना, वो मुझे ये बता रहा है कि इन लोगों ने अपना होमवर्क नहीं किया है.
अभी सर खत्म नहीं हुआ है, असाइनमेंट चल रहा है सर. एक्सपेरिमेंट का
तो बेटा
क्वेश्चन
फिर तो ये तो गड़बड़ है ये.
लिमिट उसको निकाल लेनी पड़ी थी सर.
ना ना ना, अगर असाइनमेंट चल रहा है बेटा, उसके बाद तो प्लॉटिंग हो गई, उसके बाद तो पीजेड-एक्स ट्रायंगल हो गई, रैशनल हॉराइजन डायग्राम हो गई. कहाँ कहाँ पहुंच गए तुम लोग? होमवर्क नहीं कर रहे हो भाई. गड़बड़ हो जाएगी बेटा, एग्जाम सर पे आ गए हैं.
असाइनमेंट कर रहे हैं सर, जो आपने दिए असाइनमेंट कर रहे हैं.
असाइनमेंट में सर एक्स मेरिडियन का क्वेश्चन
एक था क्वेश्चन, लेकिन उसमें लिमिट नहीं निकालनी थी.
हाँ सर.
नहीं, but you taught EM and very clearly.
असाइनमेंट का पहला क्वेश्चन था एक्स मेरिडियन.
ओके, सो आपका अभी एक्सक्यूज ये आ रहा है कि आपने तो कराया था पर असाइनमेंट में कहीं था नहीं तो हमने नहीं किया। ओके, अब एक बात ध्यान रखना बेटा, एक भी चीज जो मैंने बोली है या आपको कराई है, एक भी चीज ऐसी नहीं है जो आपके काम में नहीं आएगी। ओके, मैंने ऐसी किसी चीज को पिक ही नहीं किया जो यूजलेस है हमारे पेपर से, बिकॉज आई डोंट वांट टू ओवरलोड यू। एक भी पॉइंट मैंने अगर तुम्हें बताया है, इट हैज द पोटेंशियल टू मेक ए क्वेश्चन राइट और रॉन्ग। सो ध्यान रखना बेटा, जो जो चीजें बताई हैं कहीं ना कहीं वो चाबी किसी ना किसी ताले को लगेगी जरूर।
यस सर, करेक्ट है, वेरी ट्रू।
हाँ सर, एक्सपेरिडियन लिमिट रह गया था, वो आज देखो हो गया होगा।
हाँ, अब अगर और भी कुछ रह गया है तो उसे कंप्लीट कर लेना बेटा, नहीं तो फिर लेट पता चलेगा कि ये ताले की चाबी तो हमने प्रैक्टिस ही नहीं की। ओके
यस सर, चल रहा है सर, असाइनमेंट चल रहा है।
ओके बेटा, सो गोइंग बैक टू द क्वेश्चन नाउ। ग्रेट, सो हमें सारे के सारे स्टार्स की एक्स मेरिडियन लिमिट मिल गई है। स्पाइका की लिमिट 29 मिनट्स की है। एंड हाउ फार अवे स्पाइका फ्रॉम आवर मेरिडियन बेटा, कैन यू टेल मी?
43 मिनट।
Great. Spica is 43 minutes away. So is Spica suitable for X meridian site?
No, sir.
Excellent, beta. Great. So let me show you in the video also now the same concept.
We compare these X meridians limits obtained from nautical tables with the time to or from Marpas that is calculated. And what do we find? That except for Spica, which is outside the X meridian limits, the other three stars, Elliot, Mimosa, and Gekrux, they all are within the X meridian limits, and therefore these three stars are suitable for X meridian observation. Now, in some questions, if the R angle, like in this case, it was given to find the stars which are within 15 degrees of observer's meridian. Now, if this angle, R angle limit is not given in the question, then, and we have to perform this check for X meridian observation, then we can check the stars falling within 20 degrees of R angle from observer's meridian. So if this limit is not contained in the question, you can set this limit at 20 degrees and carry out a check that shall suffice our purpose.
Okay, beta. So that completes our question. Have a good look now. Let me know any doubts coming in anywhere. You will, beta. You will, when you pick up a factor from table 1 and you go to table number 4, if it does not match with the exact value, you will need to interpolate. Okay, but once you interpolate, you can take the limit in rounded off to nearest minutes. No need to take the seconds, because when you do interpolation, seconds will also come. So round it off to the nearest minute and then take the time.
Sir, what was the last line said that if in the question this 15 degree is not given, we will take 20 degree by ourselves, sir?
That's right, beta. अगर कोई क्वेश्चन आपसे पूछता है find the star suitable for X meridian and the question does not tell you anything about the R angle, like they have mentioned 15 degrees here, if nothing is mentioned, in that case you can take 20 degrees and solve the question.
Okay, sir.
So you're trying to say that 169, 38.6, the margin what we got was 154, 38.6, 184, 38.6. उसको 15 के जगह 20 करना है.
That is right, beta. If the value is not given, you add and subtract 20 degrees to the SHA on the meridian to get the stars.
Okay, that's all right. But any specific reason why 20 degrees?
Okay, reason भी बता देते हैं बेटा. Reason उसका ये है. Have a look at the X meridian table 4. What is the maximum limit given there, बेटा?
अरे हाँ सर, ये लास्ट टाइम मैंने ही पूछा था आपको, करेक्ट.
याद आ गया?
हाँ ओके
बता फिर बता।
So what is the maximum limit given on table 4 beta in minutes?
71.
Very good. 71 minutes is the maximum possible x meridian limit. So 71 minutes से ज्यादा अगर टाइम है तो उस केस में तो स्टार जो है वो हमें एक्स मेरिडियन के लिए सूटेबल नहीं मिलेगा. अब 71 मिनट्स में स्टार कितना ट्रेवल करते हैं दैट यू कैन इजीली फाइंड. You know stars travel 15.2.5 in 1 hour. So just punch in numbers in your calculator and tell me how much will star travel in 71 minutes?
degrees 40.
71 मिनट्स में कितना ट्रेवल करेगा बेटा स्टार?
So 71 divided by 15 degrees 02.5, right?
No beta. No.
17 degree 47 minutes.
Very good. Very good. So 17 degrees 47 minutes is the amount of R angle which the star is going to cover. Means इससे ज्यादा दूर अगर कोई स्टार है तो वो एक्स मेरिडियन के लिए तो सूटेबल नहीं हो सकता है. So हमने इसको easy to remember round off value 20 डिग्रीज में ले लिया है. अगर आप इसे 17, 47 या 18 भी ले लेते हो, even then your question will be correct. Okay, that is the reason for this 20 degrees beta, right?
Sorry, I didn't get how the guide got 17 degrees. Can anybody say?
That's homework for you today. Okay. Stars travel 15 degrees 2.5 minutes in 1 hour. How much will the star travel in 71 minutes? That is your homework for today.
So sorry sir, can you put up the last slide? I'm just going to write the last statement. Come down.
Understood बेटा? समझ गए या दोबारा बताऊं?
Yeah. No. Got it.
Sir, PDF share कर देना please sir.
Okay. अब देखो बेटा.
Can you put up the last slide?
Last slide चाहिए? Okay.
Yes.
Here it is beta.
Sir, in this first star we are saying no for the X meridian suitability. What was the reason, sir? I didn't get it.
Okay, बेटा स्टार मेरिडियन से कितना दूर है? Just see time from meridian passage. How far away from the meridian this star is?
43.16, sir.
Very good. And what is the limit of this star?
29. Yes, sir. Okay.
Okay. Got your answer?
Yes, sir. Yes. Okay. Thank you.
Great. Done, beta? Clear?
Yes, sir.
Very good. So I'm just removing the slide now. Okay. अब बेटा अगर हमें आज और थोड़ी स्पीड मिली होती तो मैं आपको टाइप नंबर 4 और 5 भी करा देता, बट आई एम नॉट टचिंग देम टुडे. ओके, सो आई एम जस्ट स्टॉपिंग इट हियर. हमने पहली 3 टाइप्स की हैं. स्टार्स विद इन ए सर्टेन आर एंगल, stars which will be suitable or visible to the observer, and number 3 stars which will be suitable for X meridian. ये 3 टाइप्स मैंने की हैं. अब मैं आपको इनके नोट्स जो हैं वो भेज रहा हूँ, उसके साथ में एक असाइनमेंट भी है. उस असाइनमेंट में आपको ये 3 टाइप के क्वेश्चन, उसमें 4 and 5 के भी होंगे. तो आप चाहो तो अभी आज रुक भी सकते हो. I have a lecture with you day after tomorrow. So day after tomorrow we will cover these type 4 and type 5 also. If you want you can start attempting the assignment after that. अगर आप आज अटेम्प्ट करना चाहते हो तो ये 3 टाइप के क्वेश्चन आप अटेम्प्ट कर लेना. ओके, 4 and 5 वाले जो क्वेश्चन हैं उनमें जो डिफरेंस होता है, हाउ टू आइडेंटिफाई, उनमें होता है स्टार्स क्रॉसिंग द मेरिडियन. अगर कोई सवाल आपको बोले फाइंड द स्टार्स क्रॉसिंग द ऑब्जर्वर्स मेरिडियन, तो वो 4 और 5 टाइप का है. उसको आपने अभी के लिए छोड़ देना है. प्लीज डोंट अटेम्प्ट दैट. मैं वो आपको संडे को कराऊंगा. ओके
ओके सर. ओके कॉपी.
ओके, सो मैं आज भेज रहा हूँ आपको, बट unnecessarily go into those crossing meridian वाला stars, उसका concept हम करेंगे संडे को. Okay. बताओ बेटा. और
Sir, can you have a quick sketch, sir? Just one diagram, sir.
Diagram for what, beta?
SHA star, including P, SHA star, and SHA star on the meridian, and LHR. That is just one sketch, sir.
Okay, बेटा अभी लो.
Thank you.
अभी बना देते हैं. ओके बेटा, मैं अभी आपको डायग्राम बना के दिखा रहा हूं, पर एक चीज उससे पहले, अगर ये ना भी समझ में आए तो टेंशन मत लेना, इसके बिना भी सवाल सॉल्व हो जाएंगे. ओके
ओके सर.
ओके, so I'm making it for this particular diagram now. Our latitude is 20 degrees north. So 20 degree north latitude के लिए ये मैंने equinoctial बना दिया. This is how equinoctial would be. This is the Q point. And the pole would be here. This is the pole. Right, beta?
Yes, sir.
अब सबसे पहले जो हमने निकाला था, the first thing, we found the SHA on the meridian. So we picked up a imaginary star. Let us say this was the star which we picked up, imaginary star. इसका हमने SHA निकाला. SHA came to 169.38.6. So I'm just writing it here, 169. This is the SHA. I'm just leaving the minutes for simplicity. 169 degree is the SHA of my meridian, which is PZQS. Right, beta?
Yes, sir.
Now we want to find the stars within 15 degrees of the observer meridian. So what do? I go 15 degrees on this side. And I draw a meridian here. And I go 15 degrees on the western side also, 15 degrees. And I draw another meridian here. So this angle is given to us as 15 degrees. Okay. Now let us say there is a star, red color star here. Now, if the SHA of the blue star is 169, what will be the SHA of the red star? Can you tell me?
SHA plus 15.
Plus 15.
Will it be plus or will it be minus? We are going eastwards.
Minus.
So 169 minus 15, the SHA of this star will be 154. You remember how we calculated the limits? This is how we calculated the limits. Okay. And ये वाला star, जो yellow star, sorry, let me make a yellow star. So this yellow star which I have made here, the SHA of this yellow star is going to be 169 plus 15. So this will be 184. Okay. Now all the stars which are within these two, let me show you the stars. There could be many stars in the sky. Okay. All these stars which have a SHA within these two values, these are the ones which we need to find out. So ये green color के सारे stars को हमने ढूंढना है. और भी बहुत सारे stars sky में हैं. You see these red stars, pink stars. इनको हमने नहीं ढूंढना है. We are interested in the green color stars. So what we did was, let me take you back to the first question. You see, हमने सबसे पहले ये लिमिट निकाली थी 154 to 184. This is the limit which I have shown here.
Right.
So this is 154 and this is 184. ये लिमिट हमने यहाँ शो कर दी है. इन्हीं के बीच में हमने ये स्टार्स निकाले थे. So I hope now it is clear.
Yes, sir. Clear, sir. Clear.
In this horizon system, we can't show the SHA, right, sir? Our angle of SHA.
You can show. You want me to show SHA?
Yes, sir.
Okay, ये लो बेटा SHA भी आ जाएगा. Let us assume Aries is here. Okay, ये red color का point मैंने बना दिया. This is Aries. Aries can be anywhere. Let us assume that Aries is here. If I draw the celestial meridian of Aries, it will be this red color meridian.
Right.
Correct?
Yes, sir.
And now let us assume this star Spica. Okay, star Spica is this one. This one, जिस पे मैंने red cross लगाया है. If you draw the meridian of star Spica, this is the meridian of star Spica. And this angle from Aries to Spica, measured westwards, is the SHA of Spica. Understood, beta?
Okay, sir. So SHA of meridian will come on the NZS, right, sir? From that Aries. If that star is on our meridian, the angle.
Now, when the star is on our meridian, let us say Spica has come to our meridian, or the blue star is on our meridian. SHA of blue star will be this.
I understand it now. Okay.
Right, beta?
Yeah, yes, sir. That's what I'm confused. Thank you, sir.
Okay. Great, beta. Clear.
Okay, sir. Can you please open question number 5, please, for the assignment?
Question number 5. Which assignment, beta? Plotting?
Assignment 2.
Okay, just give me a minute.
You can open the solution, sir. I want to ask something in the diagram.
I'll open up. Just give me a minute. Here it is, beta. Here are number 5.
Diagram. Yeah, sir. In this diagram, sir, the vessel is going 205 degree true, and we have been given 18 degree DR, sir. 1800 DR position, and the direction of vessels is 205 degrees, sir. So why they have put like the 1812 should be where they have put 1754, right? Because the vessel is moving from DR to 205.
Okay, बेटा मैं समझ गया तुम्हारा डाउट.
सेम डाउट सर.
वेरी गुड बेटा. अब ये किस को आ रहा है? आशीष को आ रहा है और किसको आ रहा है बेटा?
ध्रुव सर.
ध्रुव को आ रहा है. अब बेटा पहले मुझे एक बात बताओ, ये वाला सवाल जो है ये मैंने व्हाइट बोर्ड पे सॉल्व करके दिखाया था जब किसी और को भी ये डाउट आया था. दिखाया था? आपने देखा था?
हाँ सर, देखा था सर.
मैंने बोला था कि अगर जो सॉल्यूशन में मेथड दे रखा है उसमें डाउट आ रहा है तो इस मेथड से करो. राइट?
हाँ सर, आपने बोला था रोलर स्केल को स्लाइड करके देन यू कैन मूव द पोजीशन अकॉर्डिंगली.
मैंने बोला था कि पहले आप दोनों पीएल्स को प्लॉट करो और फिर उनको ट्रांसफर करो. पूरी डायग्राम इसकी बनाई थी बेटा व्हाइट बोर्ड पे. ये क्वेश्चन किया था मैंने. Why didn't you do it that method, बेटा? मैं ये जानना चाहता हूँ आपसे कि आपने वो मेथड यूज क्यों नहीं किया.
अरे सर, वो एक्चुअली जब आपने कराया था और जब हम कर रहे हैं उसमें काफी डिफरेंस हो गया सर टाइम में ना. तो याद नहीं रहा वो वाला, एक्चुअली मेथड नहीं याद रहा सर वो वाला.
So अब बेटा किसी के पास उसका स्क्रीनशॉट है? Anybody has that screenshot जिसका भी डाउट था बेटा?
मैं भेज देता हूँ सर मेरे पास से।
वेरी गुड, इसको बेटा व्हाट्सएप ग्रुप पे शेयर कर दो। और आशीष और ध्रुव बेटा इसका होमवर्क है आज तुम्हारा, इन दोनों को ध्यान से देखो और इसे करो। अगली क्लास में अब मैं तुमसे डाउट पूछने वाला हूँ बेटा।
हाँ करेंगे सर, करेंगे, इसीलिए सर ये पूछा ही है चीज।
हाँ, अब मैं अगली क्लास में ना मैं अब तुमसे ये डाउट पूछने वाला हूँ, इसको मैं अच्छे से पूछूंगा मैं। ओके
हाँ सर, सर ओके।
सो बेटा ये तुम मुझसे 20 चीजें पूछोगे, मैं 20 समझाऊंगा, लेकिन जो तुम्हें समझाई है अगर तुमने उसका होमवर्क नहीं किया तो फिर मैं डाउट पे डाउट मैं पूछूंगा बेटा।
हाँ जी सर, ठीक है सर। ये मैं असाइनमेंट सर अभी रिसेंटली खत्म किया है, इसमें बस ये 3 क्वेश्चन ही छोटे थे सर, ये इसीलिए मैं करते करते सर उसके बाद अगर फिर भी रहता है तो
हाँ जी करो उसको। और अगले पहले यही तुमसे पूछूंगा कि ये वाला सवाल मुझे दिखाओ कहाँ किया तुमने।
करेंगे सर,
बिल्कुल सही। अब बताओ बेटा अगला।
क्वेश्चन 6 सर एक बार
ओके, लेट्स गो टू क्वेश्चन 6। ये रहा बेटा 6 नंबर आ गया।
इसमें सर बस एक चीज पूछनी है, इसमें जो सर ऑब्जर्व लॉन्ग आया सर ऊपर, ये ऑब्जर्व लॉन्ग 159.43.7
राइट।
पहली चीज तो सर जो ये पी की वैल्यू आई है तो यहाँ पे हमने LHA अप्रॉक्स तो निकाल नहीं पाए बिकॉज DR लॉन्ग दिया नहीं था।
राइट।
तो सर तो LHA की वैल्यू डिसाइड सर कैसे करेंगे?
वेरी गुड बेटा। अब अनफॉर्चुनेटली जो भी डाउट तुम मुझसे पूछते हो ना मुझे याद रहता है। ये जो क्वेश्चन है इसका भी डाउट एग्जैक्टली किसी ने पूछा था। अब मुझे लगता है तुम दोनों ने क्लास मिस किया है
सर AM दिया हुआ है ना इसमें, तो बिफोर मेरे पास हो जाएगा।
एग्जैक्टली योगेश बिल्कुल सही बोल रहा है। ये मैंने उस टाइम तुम्हें क्वेश्चन में दिखाया भी था कि ये AM मेंशन्ड है यहाँ पे। दिस AM इज टेलिंग अस बॉडी इज ईस्ट ऑफ द मेरिडियन। बॉडी जब भी ईस्ट ऑफ मेरिडियन होती है तो LHA ग्रेटर देन 180 होता है एंड P इज इक्वल टू 360 माइनस LHA।
ओके सर, गॉट इट।
ओके, तो तुमने क्लास मिस की है बेटा वो वाली?
नहीं सर, क्लास तो नहीं, हो सकता है सर थोड़ा बहुत।
अब बेटा मैंने तो बताया नहीं, योगेश ने खुद ही बताया। हमने ये क्वेश्चन डिस्कस किया है, आई रिमेम्बर इट वेरी मच। मुझे हर एक डाउट याद है तुम्हारा।
सेम फंडा ना सर, बाद के भी एक क्वेश्चन में आ रहा है सेम टू सेम फंडा जो इसमें है ना 6 में, कि हमें वो नहीं पता तो फिर हम डिसाइड करेंगे 2 पॉसिबल LHA निकाल के कौन सा वाला पी होगा। वो याद नहीं आ रहा किस में, बट 10 से 13 में एक क्वेश्चन में है वो भी।
सो बेटा वापस डाउट रिपीट मत करो बेटा। जो चीज हमने कर ली है क्लास में एक बार, अगर आप उसको दोबारा पूछते जाओगे, सी दैट टेल्स मी वन थिंग दैट यू हैव नॉट अटेंडेड प्रॉपरली एंड उसके बाद तुमने प्रैक्टिस नहीं किया है। सो फिर तो हम उन्हीं क्वेश्चंस को मैं तो दोबारा भी समझा दूंगा बेटा, बट यू सी अगर मैं तुम्हें ये चीज समझाऊंगा दोबारा से, वी आर गोइंग टू मिस समथिंग इम्पोर्टेंट ना, राइट? सो इस चीज का ध्यान रखो बेटा। जो चीज हमने कर ली है एक बार क्लास में, दैट यू शुड प्रैक्टिस एंड देन प्रैक्टिस करने में आपको कोई डाउट आ रहा है प्लीज आस्क मी, बट इफ यू कीप आस्किंग मी सेम डाउट्स अगेन एंड अगेन, दैट्स नो यूज। समझ रहे हो बेटा? मैं तो समझा दूंगा, मेरे लिए आसान है, मेरे लिए तो दोबारा वही उसको चीज को करवाना है। इनफैक्ट दैट विल सेव मी द हैसल, इट विल स्पेंड मोर हाफ एन आवर एंड जॉब डन, but you will lose out something, you will miss out something. So please do them thoroughly. And जो चीज हम डिस्कस कर चुके हैं क्लास में बेटा वो तो क्लियर होनी चाहिए ना, isn't it? बताओ what I am saying is right or wrong?
Yes sir.
Yes sir, you're right, you're right.
हाँ प्लीज। सो बेटा जो डिस्कस हो गया, जो चीज हमने कर ली, मुझे याद है सारे डाउट जो तुमने पूछे हैं। आई रिमेम्बर ईच एंड एवरीथिंग विच यू हैव आस्क्ड। ओके, सो इसको सिंसियरली करो बेटा। इफ यू डोंट डू योर होमवर्क देन वी विल लैग बिहाइंड। ओके
Okay sir, so next class Sunday, right?
Yes.
Okay,
yeah,
sir, okay.
next class we have on Sunday beta. So Sunday we will do the remaining types. मैं आज आपको PDF भेज रहा हूँ। प्लीज डोंट डू द क्रॉसिंग मेरिडियन क्वेश्चंस। क्रॉसिंग मेरिडियन वाले हम संडे को करेंगे, बाकी के चाहो तो आप आज अटेम्प्ट करने शुरू कर सकते हो।
कल चार्ट वर्क रहेगा, राइट सर?
That's right बेटा, tomorrow। Go ahead बेटा।
तो जो PZX ट्रायंगल जो क्वेश्चंस होते हैं थोड़े उनका असाइनमेंट भेजोगे सर आप?
हाँ बेटा, that will come in the last.
ओके सर.
That will come in the last. Okay. That's right बेटा. L difference D should be less than 90. उससे भी समझ सकते हैं बेटा, पर आज उसमें मत जाओ. आज जितना मैंने कराया है just let it settle down in your brain. बाद में अगर आप बोलोगे मैं उस पर भी समझा दूंगा. ओके ओके, सो आज यहाँ रुक जाओ बेटा. अब अगर बाकी के डाउट्स भी हैं सो लेट दिस सेटल डाउन, अदरवाइज ये भी अगर निकल गया बाहर तो गड़बड़ हो जाएगी. सो लेट इट सेटल डाउन हियर एंड बाकी के जो भी डाउट्स होंगे वी विल टेक अप इन द नेक्स्ट क्लास. ओके
हाँ सर.
ओके
गुड बाय सर.
ओके बेटा. ओके बेटा, सी यू देन. बाय बाय.
ओके, जय हिंद सर.
जय हिंद बेटा. जय हिंद.
Thank you, sir. Thank you.
Thanks.